Hello everyone, this is the video shows an electric vehicle battery cooling system. Here design and implementation of electric vehicle battery cooling system using Matlab and Simulink. Here what is the future of electric vehicle battery cooling system design? Here researching and developing the future of cooling depends on since electric vehicles have become so widely used, there is a high demand for longer battery life and higher power output. To achieve this, what we can do, the battery thermal management systems will need to able to transfer heat away from the battery packs as they are charged and discharged at higher rates. And also the heat generator as a battery is used can pose safety threats to the passengers. Due to the high stress and temperature generated by the batteries, there is even higher importance on having the correct coolant and additive package. Nowadays, the leading companies, the electric vehicle manufacturing companies such as Tesla, BMW, and LG can use a traditional liquid coolant for their indirect cooling systems. The research is continued and development will be need to be done on battery packs and coolants to advance electric vehicle safety. Okay, this example show example we can get in command prompt. Just you type the following keyword, that is as the SSC fluids EV battery cooling. Otherwise, I will give the Simulink model in my YouTube channel description box. Kindly download it. You can check the EV battery cooling system design. Okay, this is a model developed by MathWorks, design of EV battery cooling system using Matlab Simscape fluid system toolbox. Here there are the cooling unit, heat battery packs, and heating cooling unit is an important one. Here you can see the model. Here the battery packs are located. The battery packs are located on the top of cold plate, which consists of cooling channels to direct the cooling liquid flow below the battery packs. Here another important blocks, heating cooling unit blocks. This heating cooling unit consists of three branches to switch operating modes to cool and heat the battery. Here the standard system input cycle, that is where the system is simulated under either FTP 75 drive cycle or fast charging scenarios with different environment temperatures. Here there are some subsystems are available here. For example, the heater, radiator, and refrigerator systems also there. When you heating cooling unit has the subsystem, so many subsystems are there. Here by using this subsystem, there are each and every representation of if there is heater represents an electrical heater for fast heating of the batteries under low temperature conditions. Similarly, the radiator uses air cooling and or heating when batteries are operated stably. Based on that, by using this model, you can configure the system inputs, drive cycles or charge cycles. Also, you can plot the battery performance in battery packs. Also, you can plot total heat flow rate in the system. Also, you can plot mechanical energy input for the cooling systems. Also, these are by using the interactive Simscape Result Explorer app available in Simscape Fluid Toolbox. You can easily see the simulation result in called SSC Explore. Here each and every blocks you can analyze the analyze the simulation output. For example, here at what is a controller input, what is our controller output, what is our drive cycle input, system inputs, what is a battery associated state of charge and speeds, and pump power, refrigerant power, all things you can see via this interactive Result Explorer, SSC Result Explorer. Also, you can use the reusable code generated by this Matlab Simulink model. By using this reusable code, you can change the battery packs, you can analyze the battery performance. Also, you can plot the total heat flow rate in the system. Also, you can plot the energy. This is important mechanical energy input for the cooling system. Also, you can analyze and reuse the content. You can develop your own model. Then this is the EV battery cooling systems having the components. First, battery packs are located on the top of a cold plate, which consists of cooling channels to direct the cooling liquid flow below the battery packs, and also the heat absorbed by the cooling liquid is transported to the heating cooling unit. The heating cooling unit having 3 branches to switch operating modes to cool or heat the battery. Here there are 3 subsystems are available in heating cooling unit. The first one is heater, and second one is radiator, and third one is refrigerant systems. The heater represent electrical heater for fast heating of the batteries under low temperature conditions. Here the radiator uses air cooling and are heating when the batteries are operated stably. The refrigerant system used for cooling the overheated batteries. Here the refrigeration cycle is represented by amount of heat flow extracted from the cooling liquid. Okay, I already mentioned what is the input is drive cycle or fast charge scenarios with different environment temperatures. Okay, this is our system input. That is normally the drive cycles recommended by the electric vehicle companies. FTP is 75 drive cycle simulations. Here the inputs is speed and current, and this is a signal builder block to check to test the speed and the current available speed. What is your current? It shows the signal builder block. Here this is one of the subsystem available in this particular electric vehicle battery cooling system model. This is the design of battery, that is a battery subsystems. Here there are four packs are available here. There's a T1 pack, T1, T2, T3, T4. The battery packs are located on the top of the cold plate. Here the cold plate consists of cooling channels to direct the cooling liquid flow below the battery packs. Here you can see T1, T2, T3, where temperature can also measure with this battery temperatures. Here another subsystem is cold plate unit. The cold plate unit is a pack of four cold cooling plate units are available here. It's a inlet and outlet liquid flow through this ABH and ABC, HA, and these are also the inlet, and this is our outlet for each and every pack. There is a pack 1, pack 2, pack 3, pack 4. Here the cooling plate unit contains pipe inlet R1, pipe inlet R2. Here this is a left hand side portion, this is a right hand side portion. Clearly shows the cold plate unit of this design of EV battery cooling system. And next one, the important unit called heating cooling unit. In this unit having 3 subsystems mainly for the refrigerant system and the radiator system and heater system. The heater represents an electrical heater for fast heating of the batteries under low temperature conditions. Similarly, for radiator uses air cooling or heating when the batteries are operated stably, and the refrigerant system used for the cooling overheated batteries. Here the cooling inlet and controller also available here. The coolant temperature also set by the user. The heating and cooling unit of the 3 branches to switch operating modes to cool and heat of the battery. This is the generate Simulink design very fair output, that is a vehicle speed and battery packs temperature and pump power and refrigerant power in terms of kilowatts. You can analyze using the logic analyzer block. Here the battery packs temperature, the 4 packs are shown in the second graph. There is a pack 1, pack 2, pack 3, pack 4, and the dotted lines shows the temperature maximum and temperature minimum. Also refers this electric vehicle battery cooling systems. Here this is the code taken from the journal IEEE International Electric Vehicle Conference Journal. The author Hureya and Carola Gazzari Jackie et al. Proposed the method high fidelity electrical model with thermal dependence for characterization and simulation of high power lithium battery cells. Here there are battery packs with current and voltage and the state of charge and temperature are analyzed in terms of times. This figure shows the performance of a series of 4 lithium ion batteries. The data used for each cell is based on the described authors. Here this is our model. Code to plot simulation result for this Simulink model, Matlab Simulink model, electric vehicle battery cooling system Simulink model. This figure shows the total heat flow rate generated by batteries, the total heat flow into the coolant, and also total heat flow rate extracted from the coolant, and also the contribution of each cooling systems. Here heat generated by battery packs and total heat flow and contribution of cooling branches also available in terms of um, time versus heat flow rate in terms of kilowatts. Here simulation results taken from Simscape logging, that is your Simscape result explorer. You can see input mechanical power versus your time and cumulative input mechanical energy to pump and refrigeration system. This figure shows the mechanical energy input for the cooling systems. Now you can see the Matlab model. It is a Simulink model. In this model, you can see whatever the mentioned blocks are available here. The heating cooling unit has the three subsystems called refrigerant system, radiator, heater, and coolant temperature. Here also the controller also used to used to control this refrigeration cycle is represented by the amount of heat flow extracted from the cooling liquid. Here these are cold to plate subsystems. Here this is the battery pack subsystem. This is the battery subsystems. Here the visualization block shows the speed, batteries, pump power, and refrigerant power. Here environment, this is our tank cooling liquid block. This block models a storage tank with the inlets in gas and thermal liquid network. The liquid pressurization changes according to the pressure of gas volume. To modify the number of liquid inlets, you can right click on the block. You can select Simscape and block choices also there. Here the controller and airstream airflow rate are designed by this pump also. This pump also shows the fixed displacement pumps. This blocks models a pump with constant volumetric displacement that supplies mechanical energy to thermal liquid network. Also, it accounts for losses due to leakage, flow, and friction torque. The pump may operate in the both forward and reverse direction, depends on the rotation of the shaft. Okay, here this port A and port B are the thermal liquid conserving ports associated with the pump inlet and outlet. Here these ports R and C are mechanical rotational conserving ports associated with the shaft and casing respectively. Here itself we can modify the values, the system inputs, speed and current. You can also see the signal builder here. Otherwise you can import your own data, import from file. You can import the data. Otherwise you can, by using the signal builder, you can give the speed and current inputs. Also after here itself we can make the simulation. After simulation we can generate code, export data and generate code, or the simulated data can be exported in terms of exported to workspace or saved as a mat file. Now we can see simulator, run the simulation. You can see the configure system inputs is drive cycles or charge cycles. You can also see the battery performance, also see the heat flow rate and mechanical energy input for the cooling systems. Also you can see. Here we are concentrating of this video is future of EV battery cooling. Nowadays the researchers are developing the future of cooling systems. Since the electric vehicles have become so widely used, there is a high demand for longer battery life and higher power output, so that we need. Okay, now we can see the output in terms of vehicle speed and battery packs. The lower dotted line given the temperature minimum, and this is where temperature maximum. These are all lying pack 1, battery pack 1, pack 2, pack 3, pack 4 battery packs in temperature, in terms of temperature. The vehicle speed, what are the inputs, and the almost the same with this one. You can see, analyze the inputs. can see the same thing. We can get this exact speed. We can see exact speeds, what is the motor speed, or we can achieve this one. Also we can see the another important aspect of this EV battery cooling system cycle is you can plot the battery performance in terms of battery packs current, voltage, and state of charge and temperature. Here itself you can get. Also based on that you can generate code also. You can generate the reusable code. Here if you click here means you will get code. Here the auto generated by Matlab at the time of running. Here itself you can change the display name and change the values, create figure values. Here here itself you can change the values, battery packs and current voltage measurement. Also you can export your data, save in workspace. And the one more thing you can see battery heat flow rate in the system, total heat flow rate. You can see the same thing, heat generated by battery packs and the total heat flow rate and the contribution of cooling branches. Also there here itself you can generate code by using this SSC fluid EV battery cooling system Simulink file. You can generate the reusable code. Also you can export the data or save the data to workspace. And then the mechanical energy input to the cooling system, that is the input mechanical power, that is a pump. The orange line shows the refrigeration systems and the blue line shows the pump power, that is the input mechanical power. Then blue line shows the cumulative input mechanical energy to pump and refrigerant systems. Also you can see the result through Simulink SSC Explorer, that is a Result Explorer app in Matlab, that is particularly available in Simscape toolbox. Here itself each and every blocks you can see the result simulation result in terms of Result Explorer. Here what are the blocks are available here, for example airflow rate, battery, and cap G1 cold plate, controller, environment, and gas properties. All the things we can see. For example airflow rate, if you want to see the airflow rate, you can see there is M and pi value, simulation statistics, zero crossings. Also you can see this is a battery block. In this battery block you can see what are the reference here, reference 1 heat flow rate sensor value, and heat flow sensor 1 value, 2 value, input current, it's a battery pack 1 temperature, also cold plate, it's a environment condition. All the things we can see. There is a what is a pipe L1 and pipe in L2. All the parts part simulation result is available here. Here this is a heating cooling unit. Here itself we can see the constant volume chamber values and simulation statics at zero crossings. In this manner you can see the statistics for the selection node. Also the number of time steps you can see, and the number of logged 0, and this is our cooling heat temperature versus our pressure loss also you can calculate. Based on that, this is an interactive app is available in Matlab toolbox called Matlab Result Explorer. Here in my channel, the one separate video is posted for this Result Explorer, Matlab Simulink Result Explorer, Simscape Result Explorer. Kindly go through this video. You can get more about this Result Explorer. Here the simulation result, by using this EV battery cooling system model, you can configure the system inputs, drive cycles or charge cycles. Also you can plot the battery performance in the battery packs, plot the heat flow rate in the system, plot mechanical energy input to the input for the cooling system. All things are available via Simscape Result Explorer. I also posted the video in this description box in Simulink file. Also I have posted here. Kindly download and use of this electric vehicle battery cooling systems. in my channel. Overall, my subscribers kindly support us. If you like this video, please like and share and comment on my videos. Thank you so much.